Hey guys, it's me, Miss Harvey. Welcome back to my channel. I missed you guys. It's only been like forever since we last talked. So I hope you had a good weekend, as good as it can be since, we're limited on what activities we can all do. But I hope that you got some fresh air and you were active and, you know, you had fun. So today I'm going to be teaching you math. It is Monday, March 23rd, if you didn't know. So that's what you need in front of you. You need your math packet. You need it open to Monday, March 23rd. If you don't have a physical packet, you need it opened online in another tab, and you need it to scroll down to Monday, March 23rd. If you are doing it on the internet, then you know that you need scratch paper because you need something to do your calculations on. And if you have the physical packet, that's where you should be working. So as a reminder, guys, you should have already gone through all the problems and solved them before you go through this video. This video is explanations on the answers, so you should have already attempted all of the questions. You should be ready to check your work with my work. So I'm going to give you a couple seconds to find whatever you need, pause this video, come back in 5 seconds, ready to go, ready to learn. Okay, so we're starting off with fact power today. I'm not going to go over all of these answers, but if you're feeling like you need to check your fact power, then you should pause the video here, take a closer look at the answers, but I'm going to scroll through them so that we can continue moving on with our lesson. The first problem that we're going to go over today is the second problem that was in the packet. Go ahead and reread it to yourself quietly so you know exactly what we're going to be discussing. So in this problem, we know that Samantha has a 2-liter pitcher in order to serve lemonade to 10 of her friends. And she wants to know how many times she's going to need to refill the pitcher or fill the pitcher in order to serve each of her friends 400 milliliters of lemonade. So the first thing you should have noticed is that this is a word problem that has conversions in it, and I have different units. So I know that I'm going to need to be doing some converting in order to get like units, because I can't do any addition or subtraction without like units. So the first thing you should be saying to yourself right now, did I do the two things that I must always do whenever I'm solving a conversion problem? Right now, I want you to say out loud to yourself, what are the two things you need to do in order to solve conversions? So you should have said you need a table and you need a number sentence. Ding, ding, ding for whoever got that right. So over to the side, you see that I have my table and I have my number sentence written out. I have liters and milliliters in the word problem, so I know that I'm going to be converting between liters and milliliters. I started off by writing out my conversion fact, which is 1 liter is equal to 1,000 milliliters, okay? So that is gonna help me figure out how many milliliters are in 2 liters. I know to go from 1 to 1,000, I multiplied by 1,000. So to go from 2 liters to milliliters, I'm gonna do 2 times 1,000, that equals 2,000. So I know that she has a pitcher that holds 2,000 milliliters. Now comes to the part B. We know that Samantha has 10 friends and she wants to serve each of them 400 milliliters. First, I need to figure out how much lemonade she needs to serve all of her friends. So I did 10 times 400 equals 4,000 milliliters. So Samantha needs 4,000 milliliters to serve all of her friends. If the pitcher holds 2,000 milliliters, we need to ask ourselves, how many times does she need to fill the pitcher in order to serve her friends the 4,000 total milliliters? So I wrote a number sentence. I will use repeated addition in order to help me figure this out. And I stopped when I got to 4,000 because I know she's only going to be serving 4,000 milliliters of lemonade. 2,000 plus 2,000 equals 4,000 milliliters. I repeatedly added 2,000 two times. So I know Samantha is going to need to fill her pitcher twice. Right now, if you're noticing for this problem, you did not use a number sentence, a table in order to do your conversion, and then you did not solve appropriately, go ahead, pause the video here, and go back through in order to edit your work so that you can get a second chance at the problem. And if you are still feeling a little bit confused after that, you should check in with your teacher, email them, G-chat them, call them, text them, so that they can conference with you on this material, okay? So the answer to the next problem, number 38, was C, 22. Pause the video here. You'll be able to take a look at my work to see the strategy that I used in order to solve. The next problem that we are going to talk about together is number 35. Reread problem number 35 to yourself so you know exactly what we're talking about. Okay, so number 35 was asking a volume question. So I know if I'm doing volume, I need to have the two volume formulas in my head ready to use whichever one works appropriately. So I wrote them out. Volume equals length times width times height. Also volume equals base times height. I wrote them out both because I'm just going to use whichever one works best here. The problem says that there are 3 boxes that are shipped on a truck. Each box has a base of 16 square feet. 2 of the boxes have a height of 3 feet and 1 box has a height of 5 feet. What is the total volume of all 3 boxes? So since I was given the base of each box, I know I should use volume equals base times height to figure out the volume here. Each box has a certain height. I need to use the word problem in order to keep track of that. 2 of the boxes have a height of 3 feet, and the other box has a height of 5 feet. Notice I organized my work. I separated my calculations for each box. If you did not do that on your paper, then I want you setting up your work as I set it up while I'm talking about it. So for box 1, I went ahead and wrote my formula down, and then I filled in the numbers that were given to me in the word problem. My base is 16 feet squared. My height is 3 feet. And then I solved. For box 2, my base is 16 feet squared. My height is 3 feet again. And then I solved. For box 3, my base is 16 feet squared. My height was 5 feet. And then I solved for my volume. But the question was asking us, what is the total volume of all 3 boxes? I know that volume is additive when I am combining figures, or in this case, I'm combining the volume of these boxes. So I added 48 plus 48 plus 80, and I got 176B. If you did not use volume formulas, and if you did not write out all of your work, including units, you're pausing the video here, you're editing your work and revising it so that it looks like strong math work and strong math calculations. The next problem that we're going to go over as a whole class is number 36. Reread number 36 to yourself quietly so that you are familiar with the problem. Okay, Lynn's goal is to drink 8 cups of water every day. She drank 37 ounces before lunch. How much more water does Lynn need to drink today to reach her goal? So I know that she wants to drink 8 cups of water, and so far she's drank 37 ounces. Well, I can't compare 8 cups and 37 ounces. Why do you think I'm saying I can't compare 8 cups and 37 ounces? If you said it was because they are not the same unit, then you're correct. This tells me a hint that I'm probably going to have to do a conversion here because I cannot compare unlike units. It's going to be impossible. So I need to figure out either I need to either convert both units to cups or both units to ounces. So on the side, I have my table and my number sentence, because whenever we're doing conversions, we should have a table and a number sentence. We recently learned these conversions, and if you're finding that you don't remember all of them, this is a really great time for you to advocate for yourself. You can always research the conversions fact instead of not solving the question. So if you don't know how many ounces are in a cup, and that's okay. You can research it on the internet in order to help you answer the question and help you memorize it. And then you'll solve the rest of the problem yourself. So, for the rest of the problems, if any other come up where you don't know the conversion, remember that that is a strategy you can use in order to help yourself. So, I know for every cup, there are 8 ounces. To go from cups to ounces, my table shows me that I must multiply by 8 because 1 times 8 equals 8. To go from ounces to cups, I know I must divide by 8 because 8 divided by 8 equals 1. I know that Lynn's goal is to drink 8 cups of water, so I filled in 8 under cups. Then I wrote a number sentence to figure out how many ounces that would be. 8 times 8 equals 64. So her goal is to drink 64 ounces of water every day. So far, she drank 37 ounces. I am going to subtract 37 ounces from 64 ounces to figure out how much more water Lynn needs to drink. And I figured out she needs to drink 27 more ounces of water. If you realize that you did not do a table and a number sentence to solve this problem, you're pausing the video here, you're revising your work. Next page, number 33 and number 34. You can see my work on the paper. You're pausing here to check your work using my strategies. 31 and 32. You're pausing the video here to check your work against mine, paying close attention to the strategies that I am using. If you notice for number 31, you did not draw a model that matches your number sentence, you should be going back and revising your work so that you have a model to match your number sentence and help you solve. For number 32, if you're noticing that you did not find common units, you're going back, redoing your work, because whenever you are subtracting fractions, you need common units. So you need to have found a common denominator in order to do that subtraction. If you have questions about these, make sure you're starring, jotting down questions that you have, and reaching out to your teacher after the video is done. Number 28 was another volume problem. If you realize that you had issues with the volume problem that I just went over earlier in the video, now is a good chance for you to pause the video, redo or recheck numbers 28 and 30 since they are both volume questions using the strategy that I just introduced to you earlier in this video in order to see if you're more successful with them this time around. If that's not the case, you're pausing the video, checking your work against my work, making sure that you are showing work for all questions and using the strategies that are on the video. Next, we are going to go over number 17 as a class. Go ahead and reread number 17 so that you're familiar with it. Okay, so for number 17, they gave you a diagram as shown with some cubes that were filled in a box. And they wanted to know how many more 1-inch cubes would be needed to fill the box completely. So this was another two-part question that you needed to solve in order to be able to find the correct answer. So if we want to figure out the volume of a figure, then that means basically we're trying to figure out the amount of space inside. So if we wanted to figure out the volume of this box, we would be using the dimensions that are given to us in order to do that. But this question is not just asking us to figure out the volume of the box. It's asking us to figure out how many more cubes would be needed to fill the box completely. So the first step would be to figure out how many cubes do we need to fill the box in the first place. That means that we need to figure out the volume of the box. In order to figure out the volume of the box, I need to do length times width times height. I'm going to use the diagram to help me figure out the length, the width, and the height of the total box. Along this side of the diagram, I see that there are 8 cubes. I know that the length must be 8 inches. Going back towards the back along the side, I know that there are 3 cubes. So that means that the width must be 3 inches. Going upwards, showing the amount of layers that would be needed, I see 5 inches. So that means that the height would be 5 inches. To completely fill the box and to find the volume of the total box, I would do 8 times 3 times 5 in order to get 120 inches cubed. But the question is asking how many more cubes are needed to completely fill the box. So we need to figure out how many cubes are in the box currently and subtract that from the total amount needed. I know I need 120 cubes in total. I need to figure out how many are currently in the box. Again, I can see that there are 8 cubes going along the length of this base, and there are 3 going along the width of the base. And then there's only 1 layer that is filled in, so I know that the height of that layer is just 1. So I can figure out the base of this box, which shows how many cubes are currently filling it. 8 times 3 would be our length times our width, and that equals 24 inches squared. So I know I need 120 inches or 120 cubes, and I already have 24 cubes. So in order to figure out how many more I need to fill the box, I do 120 minus 24. And that gets me 96 cubes needed in order to completely fill the box. For number 18, you're going ahead and checking your work. As you can see, in order to help me figure out the standard value or the standard form for each answer choice, I went ahead and solved each of the parentheses and then wrote my number in standard form. If you did not do that for answer choices A, B, C, and D, you're going ahead back to your work, revising and using that strategy in order to show how you compared numbers. Then, for each answer choice, you should be using the stacking method in order to compare the numbers. I compared the number for answer choice A to the value given to me in the word problem using the stacking method. In order to use the stacking method, I need to stack my digits by place value. Starting at the largest place value, I compare them and go to the right. As I am comparing each place value, I will be able to figure out which number is bigger or smaller based on the place values. And I know that if the digits have the same value in a certain place value, then I would move to the place value directly to the right and compare those digits and follow that procedure until I'm able to figure out which number is smaller or larger. For number 14, you're checking your work, pausing the video here, making sure you're using my strategies in order to solve the problem. Doing the same for 10 and 11. Pausing the video here, checking your work. If you're noticing that you are having problems solving certain types of questions, for example, if you are having issues solving volume questions, if you're having trouble subtracting fractions, you're writing down a note on your paper so that as soon as this video is over, you can reach out to your teacher for a conference. If you're finding that did not show the appropriate amount of work, using my work as an example for how yours should look, you should go back and revise your work so that you are showing all of your calculations. As I'm going through these pages, you're pausing the video so that you can take a longer look at questions and how I solved. You're checking your work and revising your work so that it shows all of your computations. Okay, that is the end of our math video for today. Remember, these are the 3 things that you should be taking away from this video so that you're prepared to continue doing math in the coming days. If you have a question about any of the problems or any of the strategies used, you have written them down and you're ready to go ahead and email your teacher so that they can reach out to you for a conference. During this video, you should have been pausing at each question in order to check your work against mine and to revise your work and make sure that you are using the appropriate strategies. If you're finding that you are having questions on certain types of problems, after reviewing one of them with my work, you should go back and try similar problems to it or problems that use similar strategies in order to give yourself more practice on those questions so that you can become more familiar with them. As always, if you have questions, reach out to your teachers. We're here to help you. And see you tomorrow in math class.